Welcome to my new video. Here we are going to discuss about geostrophic wind. It is a wind system. It is an important concept in meteorology and atmospheric physics, climatology, and also it is important in geography. It helps to study large-scale weather patterns or large-scale wind systems like westerlies, trade winds, so on. The term geostrophic actually comes from the Greek word geo means earth. As a geographer, all of us we know what do you mean by geo? That is earth. And strophic means turning. Actually, it is also known as geostrophic flow. It is a theoretical wind and direction. That means it's just a theory. Okay. Then we can define geostrophic wind as it is a horizontal wind that occurs due to the two important forces in the earth, which are the first one is pressure gradient force and second one is Coriolis force. So geostrophic winds are horizontal winds that occurs due to the pressure gradient force and Coriolis force that is balance each other in the atmosphere. It flows parallel to the lines of constant pressure. We know that the imaginary line that shows or that represent the constant pressure, that is called what? It is called isobars, right? It is called isobars. So it flows parallel to this line. That means geostrophic winds flows parallel to the isobars, and it's a theoretical concept used to understand large scale wind patterns. Okay, that is not representing the local winds or any other. It is used to understand this concept. Geostrophic wind is used to understand large scale wind patterns. Okay, and weather system. Theoretically, the occurrence of geostrophical wind is done by two important forces that act on the Earth's surface, that is Coriolis force and pressure gradient force. So what do you mean by Coriolis force? It is a fictitious force, right? Do you know what you mean by fictitious force? Simply, we can say when an object rotates, it experiences a centrifugal force operating radially outwards on its own reference frame, which is a non-inertial reference frame. This force does not exist at all when viewed from an inertial reference frame. It is considered a fake force for this reason. So that is Coriolis force. It is a fake force, or it is a fictitious force that is arise from the rotation of the earth. The Coriolis force occur due to the rotation of the earth that cause the object moving in the atmosphere that appear to be deflected. The moving objects in the atmosphere, that means wind or any other, it appear to be reflected. Okay, that means there is a force in the atmosphere due to the Coriolis force that occurred by the rotation of the earth. It will deflect the direction. Okay, it will deflect in the direction. If it is in the northern hemisphere, it deflect its direction into the right side. On the other hand, if it is on the southern hemisphere, it deflected direction on left side. Next one is pressure gradient force. Pressure gradient forces, on the other hand, it arises from differences in the air pressure between 2 points and cause the air to move from high pressure to low pressure. We know that winds are moving from high pressure to low pressure region horizontally, right? So these important forces on the earth, that means Coriolis force and pressure gradient force, will be in balance. That means when these forces are in balance, the resulting wind is known as geostrophic winds. Here is a pressure gradient force, here is a centrifugal force. When these forces are balancing, it results in the geostrophic winds. That means pressure gradient force is equal to centrifugal force. So it is in the northern hemisphere, it is isobars. Here we know that what is pressure gradient. Pressure gradient means the moving air from high pressure to low pressure regions. Here the air is moving from high pressure region to low pressure region, so it represents the pressure gradient effect. Then it is Coriolis force. We know that in the northern hemisphere, every body in the atmosphere, that is, these winds will deflect on left side in the northern hemisphere. What is in the case of southern hemisphere? It will deflect in the leftward side, right? So in the northern hemisphere, it will deflect to right side. Then the air, it is a stationary period, the air will blows. Then after it will be in a balancing, that means the Coriolis force arising from the earth rotation and causes air to be deflected to the right in the northern hemisphere. Then these pressure gradient force arising from the differences in air pressure over a distance, causing air to move from areas of high pressure, here high pressure and here low pressure area. In the case of geostrophical wind, we know that these two forces in balance and the resulting wind blows parallel to the line in a constant pressure. This is the line of isobar. So the air will move in a constant speed, constant velocity. Okay, it will also parallel to the contours. Then the magnitude and direction of the geostrophical wind depend on the pressure gradient and the latitude of location. Okay. Once again, the formation of geostrophical wind can be explained by the following steps. First one, the horizontal pressure gradient exists between 2 points, which are the first one is high pressure, second one is low pressure. Okay. Then the pressure gradient force causes air to flow from high pressure region to low pressure region. As the air moves, the Coriolis force acts on it. It deflects it in the right side in the northern hemisphere. In the case of southern hemisphere, it will deflect on leftwards. The deflection due to the Coriolis force result in the air moving in a circular path around the high pressure region with the direction of rotating opposite to that of the earth rotation, right? So eventually what will happen? The centrifugal force due to their circular motion balances the pressure gradient force and the resulting wind flows parallel to the isobars. Hope all of you understand this geostrophical wind and its explanation about this occurrence and so on. Thank you for watching my video.